What engineers do. Engineers solve problems. They solve problems about how to make something or how to fix things. Do you know an engineer? What does he or she do? Engineers operate systems. You have probably heard of the engineer that drives the train. What kinds of problems could an engineer solve in the driver's seat of a train? We have to remember that old-time trains were powered by steam. The train had a big wood or coal fire burning under the boiler. The boiler turned water into steam. The steam moved into big cylinders where the pressure of the steam pushed a piston back and forth. The piston provided the force to turn the wheels. The steam locomotive system was very complex. The fire had to be maintained at a steady temperature. The steam had to be delivered to the cylinders at just the right pressure. All the mechanical parts and connections in the system had to operate precisely for the train to keep chugging along. A moving train presented many opportunities for problems. It was essential to have an engineer there to solve problems while the train was moving. Modern trains have huge diesel engines. The diesel engines do not, however, turn the wheels. The diesel engines turn generators. The electricity generated on the train powers electric motors connected to the wheels. The electric motors make the train go. The train you see rumbling down the tracks is actually a giant electric train. A diesel locomotive is still a very complex system. It requires a skilled problem solver to keep the train moving properly. The engineer no longer attends to fire temperature or steam pressure. Instead, the train engineer monitors the operation of the diesel engine and the electric power coming from the generators. The engineer monitors the signal systems that keep the train safe. In addition, the engineer watches other parts of the train system, such as stations, railroad crossings, and track condition. Engineers design and improve systems. Another type of engineer is someone who helps to design or improve systems. Engineers work on all types of systems, including transportation systems. There were engineers who designed the first diesel locomotive. Like other engineers, they set out to solve a problem. The traditional steam locomotive was dangerous and dirty to operate. Burning coal produced a lot of dirty, dark smoke. The boiler might explode if it got overheated. The rail industry needed a new way to power the locomotives that pulled the long trains full of passengers and freight. The famous inventor and engineer Thomas Edison, who lived from 1847 to 1931, led a team of engineers at General Electric. This team built their first electric locomotive prototype in 1895. There were many advances in engineering during the next 40 years. The Burlington and Union Pacific Railroads began using diesel streamliners to transport passengers in 1934. Diesel-electric railroad locomotion soon became widespread in the United States. Today, engineers are designing new technologies to improve train transportation. These technologies are solving problems such as traction on the rails, braking time, and energy efficiency. Some trains are powered only by electricity, no diesel engines. Some designs make levitating trains glide on air. Some engineers are designing moving platforms that dock with high-speed trains. If you look at the first picture, the caption says, Thomas Edison was a famous engineer and inventor. At the caption at the bottom says, a maglev train uses magnetic fields to lift and drive the train. The picture up here says, these engineers are designing a robot. Engineering design practices. When faced with a problem, engineers first define the problem carefully. They decide what might make a good design to solve a problem. The characteristics of a good design are the criteria for a solution. Here is what the criteria for a solution to the locomotive problem might include. Powerful enough to pull a long line of train cars, running on an easy to use fuel that doesn't cost too much, operating on rail systems in place now. The engineers must also consider limits on the solution. The limits are the constraints placed on the solution design. Here's what the constraints placed on the locomotive problem might include: made of materials that are not easy to get, not too expensive to manufacture, designed and produced in a short amount of time, and safe for operators, passengers, and the environment. The first step to solve an engineering problem is for a team of engineers to understand the criteria and constraints. The criteria and constraints frame a solution to a problem. Next, the engineers spend time developing a plan for the design of a solution. Once they agree on a plan, they assemble the materials and tools. Then, they build a prototype. Once the prototype is built, they test it to see if it meets the criteria of a good solution. If the solution performs well, that is great. If the solution fails to measure up to the criteria, the team goes back to the original plan. They revise the plan to correct the parts of the design that didn't work. At the same time, they make sure that they honored the constraints. Is the solution cost-effective? Are all of the materials easily available? Is it safe and easy to operate? Think about the engineer who designed the first parachute. The problem was how to get objects and people from airplanes gently but quickly to the ground. He had an idea and developed a plan. He made a prototype parachute. He tested it by dropping it from various heights with different masses attached. See, the caption above the pictures at the bottom says, "An engineer designed parachutes." On page 27, the picture at the top and the caption says, "Engineers thoroughly test their designs before putting them into production." Think about the criteria for a successful solution to this problem of delivering objects and people from airplanes. The first test with bags of sand or potatoes was successful, and the design was judged to be good. Then, someone had to put the new design to the ultimate test. Someone had to jump out of an airplane 1,000 meters or more up in the air using the parachute. That's one instance where the first user had to be pretty sure all the mistakes had been corrected. Look at the yellow box at the bottom. Elements of the engineering design process. Let's review the elements of the engineering design process. Understand the problem thoroughly. Carefully define the criteria and constraints placed on a solution. Devise a plan for the solution. Test the solution and evaluate its performance. Return to the planning phase and revise the plan based on data from the test. Repeat steps 4 through 6 until the solution satisfies the criteria and constraints. And obtain a patent and go into production. How many kinds of engineers are there? There are many different problems to solve. Every kind of problem is the specialty of a different kind of engineer. Here are some different kinds of engineers and what they do. So if we start at the top, we can see the pictures that go along with the captions and the explanation. Architectural engineers. Architectural engineers design buildings and structures such as homes, hospitals, skyscrapers, warehouses, towers, and stadiums. Architectural engineers use blueprints to help them design a project. Next is aerospace engineers. Aerospace engineers design airplanes, rockets, satellites, space stations, and space shuttles. The International Space Station that orbits the Earth was designed by aerospace engineers. At the bottom, we have electrical engineers. Electrical engineers design electric circuits that perform all kinds of electronic wonders. Their designs create cell phones, digital cameras, computers, televisions, and lighting systems. The electronic components of a computer are designed and built by electrical engineers. At the top of page 29, we have chemical engineers. Chemical engineers design new materials for use by people in many different ways. They design fabrics, medicine, lubricants, and fuels. Chemical engineers design and test new products at a laboratory. In the middle, we have biomedical engineers. Biomedical engineers design new replacement parts, such as prosthetics for people. They design instruments for monitoring a person's health and new life-saving devices. They also design processes or therapies to help sick people get healthy. Designing artificial limbs or prosthesis is one way biomedical engineers help to improve a person's health and wellness. At the bottom, we have mechanical engineers. Mechanical engineers design machinery such as locomotives, cars, and motorcycles. They design smaller machines like printing presses, dental drills, electric toothbrushes, chainsaws, braking systems for bicycles, and just about every other design system that has moving parts. Large and complex machines are developed by mechanical engineers. Some other types of engineers. Computer engineers. Computer engineers design computing systems, including both the hardware and software components in computers and tablets. They design controller systems for cars, GPS systems for navigation, and cellular telephone systems. Computer engineers design computer hardware and software. In the middle, we have traffic engineers. Traffic engineers design systems for the efficient movement of vehicles and people. They design roadways and rail systems, and smaller escalators to move humans through airport terminals and sports stadiums. These engineers manage aircrafts from takeoff to landing and design and manage shipping through river systems. Air traffic control is managed by traffic engineers to make sure aircraft take off and land safely. Acoustical engineers are at the bottom. Acoustical engineers design the interior space and surface materials of theaters, concert halls, and recording studios. Acoustical engineers observe the sound and vibration in a recording studio. On page 31 at the top, we have nautical engineers. Nautical engineers focus on the design of water vehicles such as boats, military ships, cruise ships, and submarines. They also design docking facilities and safety equipment. They develop standards for use of equipment at sea. Nautical engineers design and build large ships. And lastly, we have civil engineers. Civil engineers design the support systems of people living in communities. They design water delivery systems and sewage systems. They design highway systems, bridges, dams, levees, canals, and tunnels. They also design public utility systems that provide electricity and natural gas. Civil engineers often survey construction sites.